Consider an era where energy is affordable, reliable, and safe. A future where the creation of power endangers neither the environment nor human lives. This is more probable than you may think, although it could seem like a pipe dream. Presenting the small nuclear reactor, a groundbreaking innovation that will transform everything. Nuclear energy has been a contentious issue for many years. Even though it is one of the safest and most dependable energy sources, it is also connected to environmental and safety risks. On the other hand, small nuclear reactors are a brand new form of reactor made possible by the most recent developments in nuclear technology. These small reactors may hold the answer to resolving the world's energy issue by supplying safe, economical, and sustainable electricity. Small modular reactors, or SMRs, used to produce nuclear energy, are now seeing a rise in investment. Significant sums of money are being invested in these new reactors by nations, including Canada, the US, the UK, China, and Russia. A novel form of reactor design, which claims to be more compact, affordable, safe, and effective than conventional massive nuclear facilities, has been the driving force behind this atomic renaissance. In contrast to the upwards of 1600 megawatts of big conventional reactors, SMRs are often considered nuclear reactors with an electrical output of less than 300 megawatts. They can replace outdated coal plants being decommissioned or provide electricity to places where the electrical system cannot handle gigawatts of power. Still, they need help to replace major plants one for one. SMRs are also reasonably simple to construct and extend by adding more units as necessary, thanks to the flexibility of the design. Utility companies may scale generation as needed, while maintaining control over the timing and cost of development. The development and building of SMRs have been accelerated by governments and utilities worldwide. The integration of SMRs with renewable energy sources like solar and wind still needs to be determined, as is whether the significant investment in SMRs will result in implementing these plans. Understanding the issues that SMRs address to traditional big nuclear reactors is crucial to finding the answers to these concerns. Scalability and predictable costs, which have traditionally been problematic for major nuclear facilities, are now possible with SMRs. They can also offer electricity to regions with weak grid infrastructure and replace outdated coal facilities. The promise that SMRs offer more compact, adaptable, and reliable nuclear energy is driving the increase in investment in these reactors. But it still needs to be determined whether this investment will lead to building these facilities and how they will integrate with other energy-producing methods. SMRs, or small modular reactors, address the issues with conventional big nuclear reactors. Despite being a substantial source of low-carbon power in many nations, huge atomic facilities have several drawbacks. Some of these include safety issues, high startup costs, protracted building delays, radioactive waste, and continued proliferation danger. Smaller, simpler, and containing less fuel and radioactive material than other types of SMRs. They are also simpler to construct and operate. SMRs also have smaller emergency planning zones, increasing safety and improving practicality. Using pre-made components, SMRs can decrease capital expenditures, building periods, and radioactive waste production. The lifetime cost of an SMR is calculated using the levelized cost of electricity and includes the cost of the SMR's construction, fuel, and maintenance. Compared to ample nuclear facilities, SMRs should be easier to construct and run more affordably. They can also be utilized in distant areas, are less expensive to operate and maintain, and can be combined with renewable energy sources. Waste management is one issue that SMRs have. While some designs employ completely novel fuel sources, such as thorium-based fuel cycles, the waste per power unit generated could be better than that produced by traditional uranium-based fuel cycles. Fast and breeder reactors, among other SMR types, have superior fuel use, creating less waste. Nuclear proliferation is another issue of worry. The deployment of SMRs at additional sites means that there will be greater demand for places to monitor radioactive material. The total self-sufficiency of some SMR designs, the capacity to run on the same fuel for extended periods, the installation and sealing of the reactor underground, and other factors all work to overcome this problem, making the reactor less vulnerable to terrorism or natural disasters. There is a worry about SMR's complexity compared to giant plants. There are fewer parts and typically better safety and proliferation measures in the designs, which results in less workforce and maintenance. Nevertheless, the relatively easy deployment of similar units at multiple sites has been hindered by the licensing procedure utilized by various government authorities worldwide. Compared to conventional large-scale nuclear reactors, SMRs have several advantages, but several areas of concern must be addressed. SMRs may be used with renewable energy sources and provide a variable baseload supply to complement other sources like wind and solar. However, the management of waste, the spread of nuclear technology, and the complexity of SMRs compared to conventional plants continue to be possible issues. The use of tiny nuclear reactors, in conclusion, is a groundbreaking innovation that has the potential to transform how we produce and use energy. They can power the world without hurting the environment or risking human lives, since they are secure, dependable, and reasonably priced. SMRs might be the solution to a better and more sustainable future as we continue to deal with the problems of climate change and energy security. Be a part of the change by participating in the revolution. Support modest nuclear reactors as we work to improve the planet for the coming generations.